All right, 2D. Now we've been asked to draw, we've been given a gradient function. We've been asked to draw the original function. So this is h prime x. We want h of x. And we've been given a bit of detail here. And we can see it's various points of intersection here. And we need to take some of these into account if we're going to do this correctly. This is typically an excellence question, and it demands more than just plonking a curve somewhere into the middle of it. Now, of course, the intercept here suggests the gradient is 0 at this point. So it's going to be some kind of a thing, negative graph. It's negative, so this is negative. So it's going to be a negative parabola around, looks like 1, 2, 3, 4. Yeah? So it's going to be negative around that point there. So I'm actually just going to take a ruler right now and draw a line through there. Make it a dotted line of some sort. Here we go. And there it is. Here we go. So the parabola, that is going to be the vertex. Yeah? It's going to be around that point. It's going to be symmetrical. The question is, though, was where does it cut around here? Because it's going to be something like this, yes. So we're going to have to find that out. And we're given some information here. First of all, we can see what this actual graph is. So it cuts here. That's one point, yeah. And it cuts here. So if I'm just going to draw a graph of this, this is going to be y is equal to, it's going to be plus 3 at the end, plus 3. What's the gradient? Well, the gradient is 1, 2, 3, 4 along. So 4 along. And how many down? 1, 2, 3 down, negative 3 over 4x plus 3. That's the gradient, that's the graph here. So if we integrate this, in other words, we find dy dx, oh, sorry, no. If we integrate that, we find y dash, if you like. We find y dash, therefore. Let's call that y dash. This is going to be y. So this is going to be negative 3 on 4. X is going to be squared times 2 on the bottom. X plus 3, x 1 on 1 plus c. That's what we've got. Let's tidy that up a little bit. So this is going to be negative 3x on 8. It's going to be squared plus 3x plus c. We don't know what c is, but we do know some things about it. We know it's going to cross. It says maximum height will be 5. So it's going to be going through here, and the maximum height is going to be that bit there. And that coordinate there is 4 along. Wait, 1, 2, 3, 4. Oh, there's 5 there. 4 along and 5 up. So this, I can write here, the y is 5. And I'm going to plonk an x is 4 into each of these. Negative 3. This is going to be a 4 squared on 8 plus 3 times 4 plus c. So let's see where that takes us. So we're going to end up with 4 squared. Yeah. Okay, so 4 squared is 16, 3 16s, negative 48 on 8. That's going to be a 5 is equal to that. Plus 12 plus c. So let's rewrite that as 5 is equal to, this is going to be 6 8s of 48. So negative 6 plus 12 plus c. And that's 6, 12 minus 6 is, well, 6. So it's going to be 5 is equal to 6 plus c. So c is equal to negative 1. So therefore, the point it's going to cross here will be at a point of negative 1. I'm going to write here along 0, negative 1. There is my intercept. And this point here is going to go around here, and it's going to cross at negative 1. Now, the question, of course, is will they need it so that it's symmetrical on both sides? I think we should do that. So we've got 1, 2, 3, 4, 1, 2, 3, 4. So it's going to going to go through this point here as well. So let's try and draw this as best we can. So I'll use a sharper pencil, I think. This is where I always get these wrong. So it's going to look something like this. Oh, I don't know. This is not quite what I wanted, but it's not too bad. And it's going to look something like this, yeah? So that is roughly what it's going to look like. This line here, by the way, is the x equals, and we want to write x is equal to 4 line. I don't know where it cuts these other things here, but this point here we can write in, and this point is going to be 5, 6, 7, 8. This is going to be 8 along, comma, -1. And that should be good. I think, let's have a look, 1, 2, 3 and a bit, 1, 2, 3 and a bit. I think that's good. So I would do, that's how I would answer that question. So to show the vertex very clearly, we have, and we've even labeled it. So I think that's what you would need to do in order to get full marks. And I think to do that, you would end up with an excellence if that was what they're wanting. So that's how I would answer that question there.